So, welcome to Anthony's session about inside Kubernetes, an architectural deep dive. And here comes the pain. Take it away, Anthony.
Here comes the pain. Okay. Thank you guys. I appreciate you guys having me again. This is my second time doing Groupby. Awesome way to get all good content out to a vast community. So this is Inside Kubernetes, an architectural deep dive. We're going to talk about this a little bit more at the end, but if you've been paying attention to what's going on in the major conferences and the messaging from Microsoft, Kubernetes is a thing. And now you guys know it's a thing because you're here to watch this session and learn about it and how it works within the data platform. So we're going to start off focusing kind of on Kubernetes and what it's made of. And then we're going to shift gears at the end and look at how that applies to the data platform specifically, since this is a conference that is oriented towards SQL Server and things like that. And so I'm Anthony Nocentino. I'm a consultant and trainer and founder of Nocentino Systems, where I specialize in system architecture and performance. If you've seen me present before, this is where I make a really bad joke and go, I like to make things go fast, and they were previously slow. And so that's one of my favorite activities to do, so performance engineering. I've been in school for a long time. I'm a data platform MVP, Linux Foundation certified engineer, and a friend of Redgate. There's my contact info. Go ahead and feel free to email me or hit me up on Twitter for any information or questions about today's session. I blog relatively frequently, and I'm also a Pluralsight author. This session is based off of a course that I published in January at Pluralsight, about a 3-hour course on getting started with Kubernetes. If you want access to that content for free, hit me up via email and I'll give you a 30-day trial card. That's because we're going to cover a lot of material. We have 1 hour. That way you can kind of sit down and watch that on your own and get 3 hours of content at a much deeper dive level if you need it. So again, feel free to email me for a free code if you need it. And that'll show up again later as well. So here's the things we're going to cover. We're going to talk about what is Kubernetes, right? What that really means and how it fits into your data center. And one of the main things about Kubernetes is we're going to design systems and implement them in code. And so we're going to learn the Kubernetes API and API objects, basically the building blocks on how we can construct our systems in this declarative model that we're going to learn about that is Kubernetes. We're going to look inside Kubernetes and look at its architecture and how things kind of piece together and how workload is placed into your cluster. And then we're going to look at actually deploying some applications and what it takes to build a production-ready cluster. One of the things that I like to make this joke as well is I'm the only guy that's going to tell you don't do this right away, because there's lots and lots of things you need to think about before you leverage something like Kubernetes in production. And so we're going to go through a bullet list of things that you need to think about before you need to do this for real in your production systems. And so what is Kubernetes? Long story short, it's what's called a container orchestrator. And let's start off with an analogy for that one. If you're used to using VMware, you're used to vSphere, right? vSphere has the job of placing workload on servers in your data center, figuring out where to run them, making sure that the resources are there, making sure that the storage is available and things like that. Well, guess what? That's what happens with a container orchestrator like Kubernetes. Its job is to figure out where to run your containers instead of virtual machines, find the resources in your cluster or collection of machines in your data center, make sure that there's storage there. And that's kind of the basic elements that it does, but it also provides some additional functionality where we can do things like abstract out our infrastructure. One of the things that we do have to do, we work with things like virtual machines, is be concerned with about things like, well, what's the storage infrastructure behind this particular system? What kind of processors do I have in my data center? What kind of IP scheme do I have to worry about when I deploy my applications? And Kubernetes puts a wrapper around all of that. So when I want to deploy an application or a container-based application in my data center, I don't have to really be so concerned about, is that iSCSI or Fiber Channel, or do I need 10 IP addresses and a load balancer? I don't have to worry about any of that stuff. I just tell Kubernetes, hey, I need 100 gigabytes of tier 1 storage. I need 5 servers up or 5 containers up and running behind a load balancer, and Kubernetes will make that magic happen for you. In addition to this infrastructure abstraction, where it's kind of suppressing or putting all of that stuff behind this API that we're going to look at later, it also provides this concept of desired state. In the data platform world, you might have worked with a technology called PowerShell DSC, where you say, hey, I want my servers to look like this. And PowerShell goes, it just makes that happen for you. It goes and makes the changes to your system and gets it in a desired state. You don't execute the commands to get you to that desired state. You just tell PowerShell to do that for you. Kubernetes does that as well. When I want to deploy an application and say, hey, run these 4 web servers all the time behind this IP address that is a load balancer, it's going to make that happen. And if one of those containers dies and I'm down to 3, if the resources are available, Kubernetes will just put a new container back, get me back up to 4, and I'm in a desired state at all times. And you're going to see how dramatic this is when we get into some SQL Server demonstrations at the end. when we look at things like replica sets and how they interact with SQL Server. It's going to be really cool stuff. And so let's kind of start off with the theory, I guess you could say, the Kubernetes API. Kubernetes provides this concept of API objects that basically represent the resources in our system, or really in our data center or in our cloud platform. And so these abstractions are the building blocks of how we get our systems deployed in this infrastructure, this platform that is Kubernetes, the container orchestrator. One of the primary workload elements that we're going to work with is a thing called pods, which is really your container-based applications. By now, you've probably heard the message that SQL Server is available in a container. Well, we're going to put SQL Server in a pod and deploy it in Kubernetes, right? That's the primary workload abstraction in this environment. And we're going to write code together. We're going to do this and write code and push it into the API server, and boom, Kubernetes is going to go get a SQL Server container and start it up for us. Now, controllers, we talked about that concept of going from 4 servers to 3 and back to 4 again, managing the desired state of our application. Well, that's what controllers do. And there's a collection of controllers that have different types of functionality that make sure that we're always in a desired state. And so that one that I referenced a second ago is called a replica set. If I want 4 replicas online all the time, well, that's what that replica set controller will do for me. It's going to maintain the desired state. Then we have services. Now, one of the things with kind of that ephemerality where if things kind of die and come back, or maybe I need to expand my replica set to scale out my application, well, that's going to add a lot of, change in my infrastructure. And so the pods are going to be assigned IPs. And well, I don't want to have to keep up with the IP addresses of each and every pod or container-based application that's deployed in my cluster. And so we abstract that behind a service, and that's the entry point to my application. So I point clients to that IP, and it's the job of Kubernetes to make sure that it gets back to the real pods that are up and running in our data center. Don't worry about if you kind of didn't keep up with that one. I have some graphics that we're going to go through in a second. They're also, one of the other major building blocks inside of Kubernetes is persistent storage. Clearly, Groupby is a DBA-oriented conference, which is the one thing that we really, really care about, keeping data around. And so we're going to look at some persistent storage in this session a little bit. We're not going to go too far, but we're going to use it and show you how it works with SQL Server. Now, there's many more API objects, but these are really kind of the fundamental building blocks to get our workload up and running. Right? Pods are the actual apps. Controllers make sure we stay in the desired state. Services get us access to what we've deployed in Kubernetes, and storage because, well, we care about data and making sure things stay around. Because if data stays around, we stay employed. So let's look at a Kubernetes cluster. So we looked at the API and the building blocks, like the constructs at which we can deploy apps, right? And so now we have this thing called a Kubernetes cluster where we deploy our applications into. And I'll think of a cluster as just a collection of either physical or virtual machines with CPU, disk, and RAM that we can just consume, right? And we want to deploy some apps. So as we stand up applications, it's the job of Kubernetes to make sure that it deploys those container-based applications in our cluster. And so in this case here, we see I'm just going to deploy a simple application stack that is a collection of web servers, maybe a caching server and a SQL server. And I want to make this clear. This isn't a SQL Server specific technology, Kubernetes. In fact, it's a technology platform that's been used for several years to manage full stacks, right? And so when we deploy things into Kubernetes, we can make sure all these constructs that we're working with, things like replica sets and storage, to make sure that we stay in our desired state, well, that can be applied to our whole stack, right? So I can have my web servers up and running, I can have my caching server up and running, and SQL Server up and running using all of the same technologies and techniques, and have a single surface area to manage our application stacks in our data center. And so just get the idea in your head that this is kind of what it's going to look like when we deploy apps into our Kubernetes cluster, which is really just a collection of servers in our data center or in the cloud. Now, within that cluster, there's some stuff, right? And so let's look at exploring the Kubernetes architecture. There's a special node in every Kubernetes cluster that's called the master, right? Kind of makes sense. We need someone to make decisions about what's happening in the cluster, right? And that master has some components. It's a very modular architecture, Kubernetes, in that there's some components, each of which have a single simple function that provides the things that it needs or for the infrastructure to deploy our apps. And the main thing in Kubernetes is this thing called the API server. In fact, it's also deployed as a pod on the master. In fact, all of these control plane elements that we're going to look at right now are deployed as containers, which gets into a weird chicken or egg issue when you're like, well, how do I start up these containers if the cluster's not available? But that's another day. So the API server. So the API server is where we go and affect change into the platform. all things that communicate with our Kubernetes cluster have to go through the API server. So we're going to work administratively with the API server. Kubernetes is going to work with the API server as the components exchange data. So the API server is just a stateless HTTP server that has a RESTful API that exposes all those objects that we just talked about a few seconds ago. Now, we're going to interact with the API server, and if we make changes to our system, we need somewhere to persist the changes or the objects that exist in our cluster, and that's where this thing called the cluster store comes in. The cluster store is an etcd key value data store. Don't call it a database. That'll get you like in weird fights on Twitter. And so the cluster store has the job of persistently storing the things that you create in Kubernetes. So as I hand in things to the API server and affect change to the cluster, like deploying applications or maybe make changes to an existing application, that's all going to be fed into the API server and stored persistently in the cluster store. There's this thing called the scheduler. The scheduler has the job of figuring out where to run your user-based workload in the cluster. So in addition to the master, we're going to have worker nodes, and it's the job of the scheduler to figure out where those pods that we're going to deploy need to live in the physical cluster, in the virtual machines, and the worker nodes that are in our cluster. Now, there's this other thing called the controller manager, which has the job of keeping our applications in a desired state. We talked about controllers a second ago, basically the things that are in charge of keeping things in a desired state. That's the job of the controller manager, making sure that we stay in a desired state. Now, in addition to that, we have this thing called oh man, I've been in like a Twitter joking war. If you go ahead and look at my tweets for the last couple hours, you're going to see a lot of commentary on how to pronounce this, whether it's kubectl, kubecontrol, or kubectl. In the end, I don't care, right? I call it kubectl, and that's because of how I feel, but there's other people that feel other ways. But kubectl is the administrative tool to interact with the cluster. And so that's how we're going to affect change to tell Kubernetes what to do. kubectl talks to the API server over HTTP, right? So it's a simple command line utility that talks to the API server over HTTP or HTTPS if you're using SSL, which if you're building Kubernetes on a modern platform, it's going to be over SSL. So in addition to that, so kubectl being the administrative command line tool, we're going to use it a bunch today in the demonstrations. We have a node. A node has a kubelet, which has the responsibility of talking to the API server in finding out what has to happen on the node. If I have to deploy an app, that's going to be messaged to the kubelet, and the kubelet's going to affect that change locally on the worker node. Stand up a pod, stand up a service, things like that. kubeproxy has the responsibility of bridging the network services from inside the pod onto the real wire on the network. So if I need to expose a service that is going to be running on a container-based application in this node, well, the way that it's going to get onto the real wire in my data center is through the kubeproxy. That's going to also talk to the API server, monitoring for any change events that need to occur. Now, there's this thing called the container runtime on all the nodes in our cluster. The container runtime by default in Kubernetes is Docker. There's other container runtimes that you can use, but if you just go and install Kubernetes out of the box, you're getting Docker. What it means is any container-based application that's compliant with Docker, chances are it can run in Kubernetes A-OK. And the container runtime has the responsibility of pulling the container down from the container registry and starting it up on the local node. In the end, that's all Kubernetes' job is to make sure that the container runtime stands up the container in the right way with the configuration that you've asserted in your environment. So that's kind of the deep dive into the cluster level things. Let's kind of focus now on some of those controller operations that we introduced a second ago and how those work inside of our cluster. So here we have a 2-node cluster with a master node. And let's say I go ahead and effect some change in the cluster with kubectl. I'm like, hey, Kubernetes, I need you to stand up a replica set of 3 pods for whatever application it is. Let's just say a simple web server application. It's the job of Kubernetes to figure out where to run that workload in my cluster, right? And so it goes ahead and deploys those 3 pods that I asked for in the cluster somewhere based on the physical resources that are available in the cluster. And it's the scheduler's job to figure out where to run that workload. So here we have our 3 nodes or our 3 pods up and running. Everybody's happy, right? The controller manager is making sure we're in a desired state with 3 replicas online at all times. And then maybe something bad happens, like we get a network partition, the node dies, whatever occurred, but we lost the pod, right? The controller manager is like, man, this is a bad scene. What are we going to do about this? I know, we're going to add another pod. And it's going to happen within a matter of seconds to get that back up and running. And if you've ever had a pager or an email account in your life and they got alerts sent to it, you didn't get paged there. Maybe you did for some warning, but chances are that probably got through whatever monitoring system you have and resolved that issue before you even got notified, because that's how fast we're going to move when we use things like Kubernetes. And we're going to talk about containers and things like that and how that all works a little bit later. But in the end, we didn't get paged. Our application stayed in its desired state and we can move on. So that's a replica set, right? Something changes. It's the job of the controller manager to make sure that we stay in that state. The replica set is the API object that helps us model that type of system. So with that change, right, chances are that pod that got redeployed had a different IP address. And so we're going to learn now how we get workload from our users into those container-based applications or pods. And as things change around, and we're going to learn now how that all works. So we make sure that we always point our users or our clients at one IP address so they can get access to the services that they need to have exposed. And so let's zoom out a little bit and look at this from the cluster level again, whereas a second ago we were looking at it from the node level. And in this time, I'm going to declare a replica set. This replica set's going to have some workload in it. Let's see how many pods I have. And this one, 4. Awesome. So 4 pods are up and running. And I want to expose the applications that run on these pods or these containers to the world. And what I'm going to do is declare a service, right? And that service is an API construct available in the Kubernetes API that allows me to declare something to give people persistent access to this application. Now, there are some additional things that we have to define. We have to tell it what protocol the service is running on, and we're also going to get an IP address from the cluster that's going to be persistent for the lifetime of that service. And so all of our clients are coming in from wherever they come into, they're going to hit that HTTP server front-ended by the service. And it's the responsibility of Kubernetes to distribute that workload to all those pods behind the scenes, right? And so a very simple way to get good load balancing to the workload that's available in those pods. Now, we're running in a replica set. We looked at a second ago, something dies, what happens? Well, in this scenario, since we are running in a replica set, let's kind of walk through what happens when a pod dies. The first thing that's going to happen is the service is going to be like, all right, bad scene. I can't reach that pod. Deregister it from the IP load balancer. So workload is no longer going to that IP address that was at that pod. The replica set's like, all right, well, that's a bad scene. I'm down to 3 pods, but I really needed 4, which is what was declared in the desired state for this particular application. Kubernetes is going to kill that pod if there was any kind of remnants left of it and deploy a new one. It's going to deploy the new one, register that pod's IP into the service, and start distributing it workload to it right away. Again, we didn't get paged. This stuff just happens automatically for us, right? Awesome stuff. And if you've ever run a data center where you have front-end applications and this stuff happens and you find out like this is all auto-healing, all behind the scenes. Very cool technology. So let's kind of zoom out a little bit further. We talked about replica sets, and no one actually deploys replica sets directly. You deploy a thing called a deployment, which is a special, I don't say a special type of controller, is a type of controller that we're going to work with. In a deployment, it allows us to declaratively move between versions of replica sets. It sounds really fancy, but you're going to watch. This is a really cool technique. Again, if you've ever had to push code out into production, this is going to be mind-blowing. I taught this class I taught a full-day workshop at SQL Saturday Chicago this year. One of my customers was in the workshop, and I know some of the challenges they have, and I showed a deeper dive module just on deployments, and I could see his face. He was just astonished by how impactful this would be on their production environment and how they roll out code. And so let's talk about a deployment now. No one deploys replica sets directly. You deploy a deployment, which is going to instantiate a replica set for you. And so let's go ahead and walk through that. When I deploy a deployment and say, hey, Kubernetes, I want you to run my application, let's say pods, version 1 of my application. Now, in this case, I'm going to have 2 pods up and running in my replica set. So my deployment instantiates a replica set. My replica set instantiates the number of required pods for that replica set. So 2 in this case. Awesome. We go ahead and we front end that with a service just like we did a second ago. So this is basically the application stack when you're deploying pods in Kubernetes. You have a deployment and you have a service. Now, what Kubernetes gives you the ability to do with a deployment is move between versions of deployments, all right? So let's say I have version 1 of my application out online today, and a developer's like, hey, guess what? V2, roll it out, all right? Here's how you do that. You tell Kubernetes, I have a new container image, run it for this deployment. All right, well, Kubernetes is going to do this. It's going to stand up another replica set. And what it's going to start doing is moving the workload and deploying the version 2 pod into the other replica set for you automatically, right? As pods shut down in the old replica set, they're going to get deregistered from the service. As they start up in the new replica set, they're going to get registered into the service, and you just move between the two versions of your applications with zero downtime. I mean, obviously there's like application things we need to worry about, but effectively we can get between two versions of our application with no downtime. What's even greater is this, that old replica set doesn't go away right away. If something goes wrong, I can just, hey, Kubernetes roll back, and it'll roll back to version 1 of my application. When we get into the demos later, I'm going to show you, we're going to move from CU11 to CU12 with the same technique, right? And you're going to see this in like less than a second or less than 30 seconds. We're going to move between versions of CUs. And then I'm going to be like, you know what? That was bad. I want to roll back. And then we're going to roll back to versions or to CU11 in the demos. And so that's going to be a very exciting thing to see. All right, so far we've talked about the architecture, we've talked about some of the building blocks or the constructs that are available, like controllers and services and things like that. Well, how do we tell Kubernetes what to do, right? So let's talk about how we deploy applications in Kubernetes, and we do that a couple of ways. We do that with, let's start off with kind of the difference between imperative and declarative configurations. And so imperative configurations is probably something that we're all used to, right? We execute some commands, we make some changes to our servers, and we're like, you know what, don't ever touch that. That's the gold image, leave it up and running, it's in production, right? And we were like, you know, that's kind of one of the, I don't want to use that analogy right now, but that's how we've built systems for years, right? We build systems and we leave them perfectly in place in production. Well, shift that model around into what's called a declarative model, where we don't tell the system exactly what we want it to do. We just tell the system what we want it to look like, right? We just say, I want 4 servers up and running now. I don't really care about where you run those. That's for you to figure out, Kubernetes, but I just want this to happen for me. And as T-SQL programmers, you're familiar with this paradigm, right? In declarative techniques, like in T-SQL, you don't tell SQL Server how to retrieve stuff off the disks or where to allocate memory. You're just like, you know, hey, SQL Server, give me this data from this table, right? That's a declarative programming model. And we're going to use a declarative programming model in Kubernetes to tell it what we want it to do. Now, the way that we do that, or the languages that we do that in, are going to be in YAML or JSON. Generally speaking, people use YAML and computers use JSON, right? But of course, if you're one of those weird developer types, you can use JSON and interact with Kubernetes, but we can talk about that and who hurt you in an earlier life. And so YAML and JSON, we're going to use YAML in how we build our infrastructure in Kubernetes, and let's do that now. So declarative deployments in Kubernetes, right? We're going to declare or use declarative techniques to define what we want Kubernetes to do. And in Kubernetes, when you write these scripts that you deploy into your API server, it's called a manifest, right? So I have a manifest that describes what I want Kubernetes to do. And the manifest is simply a text file in YAML that I'm going to feed into the API server. Now, the very, very first thing that we have to do when we're writing this is we're going to go through kind of the insides of a script of a Kubernetes deployment manifest. And the very, very first line you're going to see in any Kubernetes manifest is this thing called an API version. This has nothing to do with, or I shouldn't say nothing to do, but it's loosely coupled to the actual version of the software. It's the API version is more like the versions of the objects that are exposed in the API server. And what that does, it gives us some persistency over time as Kubernetes moves forward. I know that if I'm consuming the version 1 of the API, that all the objects in version 1 look this way, right? Because we're going to be defining our systems in code. And if the API is changing out from underneath us, that could be bad news because then our code becomes less portable, right? So we're going to stick with versioning of our, Kubernetes gives us this ability to version the API objects so that we can consume those and get some persistency in what those things look like. Now, the objects are going to be declared with a thing called kind. So we say kind pod. So in this case, we're going to declare that we want Kubernetes to build a pod for us. We need to give it some metadata. We're going to give it a name. So in this case, we're going to build a little web server called Nginx, which is a web server that is a pretty small container. It's one of the reasons why I use it in demonstrations. It's good for that. The final thing that we need is a spec. And inside of a spec, I like to think of that as the technical specification for the thing that we're building, right? We're building a pod, and a pod has to consist of some things. In this case, a pod is going to consist of a container. That container is also going to have a name because in Kubernetes, pods can have multiple containers deployed inside of them. If your applications are very tightly coupled together, chances are there are design patterns where you'd put more than one container inside of a pod. And some people ask, well, would I put my web server and my app servers in the same pod? No. you decouple those on functionality, right? You put your web servers over here so you can expand and contract those dynamically to, and you put your database servers over here inside the cluster, and you can expand and contract those independently of each other. If they were tightly coupled in the fact where we had a web server and a database server in the same pod, well, you can't really scale that out because I'd get a web server and a database server in every pod. So that's not a common or not a design pattern that you want to go after. So the spec has a containers. The containers is a list of containers available. In this case, we're just going to do one, and we're going to name it Nginx. It's going to have an image. If you've used Docker, you've typed Docker pull and you download whatever container-based image that you're working with. That's literally what you'd put right there. In this case, I'm using Nginx, and later in the demonstrations, we're going to use mcr.microsoft.com/SQL Server, and that's going to live there. In this case, our application has to be available on the network, and it's going to run on port 80. So that's the container port that's running where our application is, not the port associated with the service. That's declared separately from the pod. And so this is it. We take this thing and we tell Kubernetes, hey, kubectl. I'm going to pause there awkwardly and let everyone think about how that's really pronounced. We say kubectl. We're going to apply this configuration -f from file. So we save all of this stuff into a YAML file, nginx.yaml, and that goes into the API server and is deployed inside of our cluster. And so let's kind of walk through the process of what Kubernetes does when I say, hey, kubectl apply and do this thing. And so when I'm at the command line and I say, hey, kubectl apply, what's Kubernetes going to do? Well, it's got to figure out a lot of things before it stands up that workload. And let's walk through all of that. First off, kubectl talks to the API server over HTTP. It reads our file in YAML and converts it to JSON and sends it into the API server. Remember, computers talk JSON, not people. So kubectl apply API server. The API server does a couple of things right off the bat. It authenticates who you are to make sure that you're allowed to log into this API server. It also authorizes, can you do the thing that you're asking it to do, create a pod in this case. Now, if the next thing it's going to do is validate the configuration. It's going to look at what you're feeding it in and say, hey, is this like a valid config? If not, it's going to spit it back out and give you the errors to go ahead and fix that. And so in this case, let's say we're starting up a replica set of some number of pods, right? So kubectl apply, we've authorized it, we've stored it, or we've authorized and authenticated it, we pass it through the API server, we've passed validation. The first thing that Kubernetes is going to do is store that information in the cluster store, right? In that persistent data store so that we have that stuff over time. That cluster store doesn't, stores that information that we want to start up a replica set of 3 pods, let's say in this case. The cluster store then is like, all right, well, I have something to do, and it sends a message to the controller manager via the API server so that the controller manager stands up the replica set. And it's like, all right, well, I need to start 3 pods. The controller manager stores that information back in a cluster store that there's time to go ahead and start up 3 pods. So you see 1, 2, 3 pods get stored in the cluster store. The cluster store then messages the scheduler. It's like, hey, I need you to figure out where to run these 3 pods. The scheduler figures out where to run the workload in the cluster and stores that information back in a cluster store. And so now we have all of that information stored in the cluster store, the fact that we're running a replica set, we're running 3 pods, and where we're going to run them in our cluster. But no workload has started yet. It's the responsibility of, I forgot to walk through my build gurus there. It's a responsibility of the kubelet on the individual node to poll the API server and say, hey, do you have any work for me? When the kubelet sees that the API server has work for it, it then starts up that container or sends a message to the container on the node, which then starts up the pod on that individual cluster. And so that state is persisted in the cluster store, and it's the job of the node to poll the API server to ask, hey, do you have any work for me? And if there was a service exposed, it also goes ahead and affects that change as well. And so that's how apps are deployed inside of Kubernetes as it flows through all of these different components inside of our cluster. So here's where we're going to shift gears and look at this from a SQL Server standpoint now. So we kind of have all the tips and techniques on if we want to deploy the SQL Server in Kubernetes. Now let's shift it and be more specific to SQL Server technologies and techniques. So if you download code from Microsoft on how to deploy SQL Server in Kubernetes, these are all the things that are going to be in the YAML files that you can simply download and go. But now you know what all these things are. We're going to see how we can affect that change in our cluster. So we're going to use the same constructs that we've talked about, but in this case, we're going to talk about how SQL Server looks inside of Kubernetes. So we have a cluster, we're going to have a service, and the very first thing we're going to do is say we're going to deploy SQL Server as a deployment in Kubernetes, which is going to instantiate a replica set, right? And so in this case, it's going to go ahead and pull down, let's say, SQL Server version 1 of the container, whatever version we want to deploy. We're able to declare storage externally to the pod, right? And so they're basically two decoupled elements now. We have storage in our cluster in this thing called a persistent volume and a persistent volume claim that just lives in our cluster, just like any other resource. The SQL Server pod, or the container that's in the replica set, we tell Kubernetes, hey, we want you to put these two things together. And so as long as Kubernetes puts a container in front of that storage, we have access to the things that are inside of that storage. And so the very first thing that happens when SQL Server starts up inside of a container is, or even outside of a container, if you're using SQL Server on Linux, is it's like, all right, well, I don't have a master database or any of the system databases available to me. So the very first thing that's going to do when it starts up is put those databases onto that storage, because we're going to mount that storage in a location that SQL Server expects the data files to be in. We're going to look at the internals of that in a little bit. And so the replica set starts up, the storage is attached, SQL Server starts up inside of the pod, inside of the replica set, drops down the databases onto the storage in the file location that we've attached that storage into, right? We create a user database. That's going to get written to the storage. The metadata about that's going to get written into the master database, which lives on that storage, right? Which is going to be very valuable in a second when I show you some cool stuff. So the thing about Kubernetes is that SQL Server pod, if it dies and goes away and comes back, it's always going to go back to the container image, right? It's a little bit different than Docker. If you have Docker up and running, and you can kind of persist the lifetime of your container, kind of bring it forward a little bit. But when I kill that pod, I'm going to go back to the container-based image at all times. So that's why it's so important to keep the databases and the things outside of the container, which is great because now I can just put a container in front of there at any point in time as long as I can get access to the data. And so let's go through some other stuff about how this is going to work. So replica sets, it's the one value that we learned that replica sets provides. We're going to front end that with the service. If our container dies, what's the responsibility of Kubernetes to do right now? Put a container back. We basically got high availability in our cluster with no SQL Server specific technologies, right? Container dies, Kubernetes puts one back within seconds. You're going to see this when we do this in the demos. It's remarkable. All right, let's leverage another technique. Let's say we want to move between versions of SQL Server, leveraging a deployment inside of Kubernetes. Well, all right, I want to move between SQL Server v1 and go over to SQL Server v2, whatever that is. And Kubernetes will stand up the new replica set, shut down the old SQL Server, start up the new SQL Server, move the storage. I now have upgraded my system from SQL Server v1 to v2, whatever that is. Now, we all know as DBAs, there's stuff in internals I have to worry about and tests and things like that. But when was the last time you could upgrade your SQL Server infrastructure with one line of code and walk away and have it done in about 10 seconds? You're going to see me do this in a little bit, and it's really cool. Our users didn't have to change where they were pointed to. None of our apps had to change because all that's abstracted out into the service. The service is going to just start distributing the workload to that new replica set, right? All of that's happening behind the scenes. And so we've done those tips, tricks, and techniques over the years, like DNS aliases and things like that in our application configuration, but all that's just handled for you inside the cluster now. We don't have to do that.
On a related question from the audience, Hiram asked previously, why is the IP changing? What do you mean it has to re-register the IP to the service? Can the IP of the pod be static and just reconnect when it spins up?
So we'll go back to the services real quick. So we don't want to get in the business of maintaining that configuration. The configuration is going to be just something that we consume from, or that Kubernetes manages for us. So the pods are going to have dynamic IP addresses, but the services can have both either dynamic or static IPs, and we'll point our apps to those. And so the idea is, if I want to take this application stack and pick it up and deploy it in another data center, in another cloud, I can take the YAML code and do that in another data center. If it's pinned to specific IP addresses in that infrastructure, then I lose that portability. And in addition to just doing the other data centers, down-level environments is a common technique where I take my entire application stack defined in YAML, and I just want to pick it up and move it over here, right? And if we pin it to specific IPs, then we get into that infrastructure-specific configuration, which really reduces the portability of our apps, and also increases the support. I don't want to say increase, but yeah, it reduces the ability for us to move around our apps in our data center. And so, any other ones you want to cover?
There was a follow-up question. How quick have you seen the failover of the replica sets occur? Is it faster or the same as an AG failover to a sync node?
So sync nodes, I don't want to say it depends, but it does depend. In the end, we still have to deal with like log recovery. Like when SQL Server crashes and start up, we still have to do crash recovery. That still has to happen. But there's no concept of like a send queue or a redo queue, which are other things that can impact the failover time of an AG, right? And so it really depends on that. There are AGs in Kubernetes coming in 2019 that leverage a different, I'll say different type, but another storage model inside of, or another controller model inside of Kubernetes, where we'll have the ability to have multiple copies of the data inside of our cluster too. So there's a lot of value there. But failover times are going to be really specific. For me, it's going to be things like transaction recovery are going to be the biggest things that slow it up. But the ability to recognize that there is a failure in that sense, like lease timeouts and things like that, and session timeouts, I think is going to be a little quicker, but it's also a tunable parameter as well. And so let's just do it. I'll show you guys, and we're going to do it right now. So we're in demo land now. Yo.
Just a quick question related to that. If I'm tracking with what you've been saying so far, I mean, it sounds structurally very similar to what people might be used to with failover cluster instances, right? So I would think that, analogy. Yeah, so I would think that the recovery times would be similar to that kind of, much closer to that kind of scenario than say like an AG or something like that. Is that?
Yeah.
Okay.
Yeah, because in AGs, you have to deal with any potential queuing. In failover clusters, yeah, you're basically stopping an instance and starting an instance. So yeah, it would be very similar.
Exactly. Cool.
So let's do it. So I have a cluster that's running on my laptop. You can probably hear the fans screaming over the audio. And this cluster has 3 nodes actually. And we're going to deploy SQL Server in a deployment. We're going to do the recovery stuff. And we're also going to upgrade SQL Server. We're going to go from 11 to 12, have a whoops moment, and go back to 11. And you guys are going to see how that all pieces together. Now, so the code will be available to you guys. But a lot of it, I want to say, so the code will be available to you guys. And in this case, I'm just going to go ahead and just set up some environment variables and things like that so that I don't have to type my passwords and things like that over and over again. We can store passwords inside of Kubernetes in the cluster store as a secret. So if you're familiar with like an Azure with like a key vault where you store and retrieve things, very similar conceptually to that. This is going to be the thing that we're going to feed into as the SA password for our pod that's going to stand up. Remember I talked about how it goes back to the container-based image every time? Well, in this case, when a pod starts up, it's going to feed in the secret and start up the pod and get that going. We have some storage configuration and our deployment. I'm going to go ahead and show you guys the deployment so you guys can see what that code looks like. Let's see, that's going to be deployment SQL YAML. And so here's how we deploy SQL Server in Kubernetes. So we looked at the manifests and things like that earlier. So we know we have an API version. The object that we're going to consume is a deployment, and we're going to give it a name that is SQL Server or MySQL deployment or MSS SQL deployment. That'd be really kind of funny if I did have it as MySQL deployment. Anyway, so we have a spec, which is kind of, like I said, the technical specification for the thing that we want to build, which we have here is replicas. We're going to define one replica is up and running at all times. We're going to use the rollout strategy called recreate. There's 2 different types of rollout strategies. We want to move between versions of our application. One's called rolling update. One's called recreate. Rolling update will keep some pods up and running as it starts up the new pod and shuts down the other one. Well, in a database system, that could be bad news if I potentially have 2 pods up and running, accessing the same data files. So we use a technique called recreate, which is what I showed in the demo or in the presentation portion, where we shut down the first pod and then start up the other pod. And so that's what it's going to do that for us there. It's going to jump down here to our spec. Or excuse me, let's go ahead and, so this is the spec for the template. Or excuse me, this is the spec for the deployment. This template is the thing that is going to be instantiated by the deployment. So this basically is the metadata for the replica set. So here we see in the spec for the replica set, in this case, we're going to have a container that is going to be named MSSQL, and it's going to run this container image, right? So we're going to run 2017 CU11. It lives on 1433, and we're going to declare some environment variables. We have to accept the EULA, and we're going to go ahead and we're going to set the SA password, which is going to come from the secret store, which we just set a second ago. Now I have some mounts and things like that for where the data is going to live. The data is going to be mounted inside the container in var opt MSSQL. So if you've worked with SQL Server on Linux, that's the default data location for where databases, both user and system databases, live inside of SQL Server on Linux. We're going to expose that as a service. So here is how we can define another object in a single YAML file. We just start over again. We put 3 dashes and we start over again. We define a service. We're going to go ahead and say our service lives on this IP, and it's going to load balance to that IP. So our apps are going to connect here to an application that lives here. So let's go ahead and close that. Now, how many of you have ever installed SQL Server this fast? Uh-oh. App v1. I think I know what the issue is. Selector field. Of course, there's an issue now, right? I'm trying to be like, oh, it's so fast. All right, hang tight. Let me see. Required error.
Did you rename the MySQL to MSSQL?
I think I put it back though, but I will check that. Ooh, MSSQL recreate. It's barking about selector field and apps deployment. I thought I had selectors in there. All right, hold on. Look, edit this out, please.
I'll just sing a little song.
Yeah, right. Don't worry, I have a backup. I did this.
Still have 140 participants. It's not that bad.
Oh, cool. All right. Everyone's like, why? Why? All right, there we go.
I thought you were good at this, man.
Right. Well, you know, the funny thing is when you are doing these kind of things, there is value in seeing when things go wrong. So let me show you what tipped me off there as to what went wrong. So here we see, remember I told you when we feed into the API server, a couple of things happen: authentication, authorization, validation, right? We failed validation, right? And so here we see a validation error, right? Because there is a missing required field called selector in the object type deployment spec, right? So basically somewhere in this YAML, in the deployment spec right here, in that part, because this spec is associated with the deployment, I'd mess something up. Now, let's go ahead and unmess something up because I have this stored in a, okay, I know, I have this stored in another part of my file system. And of course, that one's messed up too. Apps, so v1, let's go beta 1. There we go, okay. Anthony yesterday was moving between versions of the API. Remember how I told you? All right, so again, we're gonna use the fact that my demo kind of got a little wonky as an educational experience. Yesterday, I moved the API version to v1, right? And remember when we talked about versioning of API objects, that we want to use a particular one for the configurations that we write, because if we move to a newer version of the API, there could be a breaking change, right? So we'd have to modify our code, and this gives us the stability to make sure that our apps are going to be running the same way at all times. And so I changed it yesterday from apps v1 beta 1 to just v1. And now we're back to v1 beta 1, and then boom, it deployed. Now this specific error has to do with having selectors defined here in the spec. And I could have wrote that code real fast, but that would have gotten a little wonkier. And so I figured an easier gateway out would have just be to roll back to the previous version of the API. So clearly the v1 wants to have additional data defined in the deployment spec here. And that's why it was yelling at me to go ahead and make sure that I had that defined. So now we have SQL Server up and running. So I went ahead and ran that code. And you can see the first time it went ahead and created it, and it created our service. And the second time I ran it just to double check, and it's unchanged. So that thing is up and running and is in our cluster, fingers crossed, hopefully. So let's move forward. And we deployed a deployment and we front-ended it with a service, right? Well, we need to know something about our service, like what its IP address is. And so we can ask Kubernetes, hey, Kubernetes, give me, so get the information about the service. So we're going to use kubectl to get the service, and it's going to give us the metadata about all of the services that are up and running in our cluster. This is where the cluster API lives. This is the service that we just deployed for our service. So this is where we're going to point our applications to, and that IP will be persistent for the life of that service or we can have it be a static IP, but in this case, I'm using DHCP internal to my cluster. I'm going to use some command line magic to store that in an environment variable here. And I'm also going to store the port in an environment variable because I'm going to use this over and over again in the rest of the demo. And so the very first thing that we're going to do is say, hey, SQL Server, what's your server name and what's your version? We're going to use SQL CMD. We're going to feed in the server IP and port and the password. I'm going to run that code. And we should see, it's going to be one of those days, team. It's going to be one of those days. Let's echo server IP. Something is not up and running. So we'll do kubectl get pods, container create configure. All right. Now we're going to use this from, I literally practiced this yesterday between 3 and 4. It was on my schedule, ran all of the demos without an issue. And here we are. So container create configure. Let's go ahead and now troubleshoot this. Let's figure out what's going on. I can say kubectl log and get the logs for my deployment. So here we see this is the resource that was created by Kubernetes. Logs. Bad request container. All right, so cube, then we're going to use kubectl describe. Nope, not that. Kubectl describe. Don't have a resource. This is getting ugly. Kubectl get pods. Create config error. Deployment SQL. So that's going to go back to the container create. It
was actually built as a troubleshooting session as well, right?
Tell me about it, right?
So you're getting lots of love for your thinking on your feet.
Oh, thank you.
Strategy.
Kubectl describe. All right, so describe deployment MSSQL. All right, and describe. Okay. So, all right, so let me walk through what I did there so you guys aren't left in the dark. So clearly what is happening is when I tried to connect to my application, it was like, hey, my app's not there. Oh, that's bad, right? And so the first thing I did was I was like, hey, the first thing I did was like, what's the status of my pods? So I typed kubectl get pods, right? And that gave me this information. So I said kubectl get pods. And then it says create container configure. So something is wrong with the configuration of the container that I'm trying to deploy in Kubernetes. Cool. All right. So then I tried to look at some logs and I wasn't getting some information that I wanted there. And then I used this command kubectl describe. What I forgot to do the first time I used kubectl describe is I needed to define the resource. And so I was kind of floundering saying, hey, what are the pods that are up and running? Let me look at the logs. I had no logs because the container never started. So I went back to describe, which I needed to say, I forgot to type in the resource type. So kubectl describe pod, and which is the resource type, right? The kind. And then I was like, here's the name of the pod that I want to troubleshoot. So the pod is, remember, is the instantiated version of the application that should be up and running, but for some reason it's not up and running. So kubectl describe gives us like a very, very verbose amount of data about what's going on inside the deployment. At the bottom here is basically an event log, right? And then boom, right away. Something is wrong with the secret that was deployed in the cluster. And so I went back up here and let's go ahead and I must have not run this code. I must have just talked about it and never ran that. That's exactly what happened. So let's scroll back down now and do this. Since that container or that pod that's up and running, we could wait for the life cycle and just redeploy on its own. But this is being recorded and I have only an hour. And so what I'm going to do is actually delete that pod, kubectl delete pod. I'm going to kill that pod off. It's going to kill that, delete that pod, deploy a new one, pull the secret, start the container. Fingers crossed this all works, and we'll see it in a second. How are we doing on time, team? 10 minutes. I think we'll be okay. All right. So let's start this over again. We'll do a kubectl get pods. All right, up and running. So clearly I talked about defining a secret. I never defined the secret. And then that was the container configuration error. So now you guys know how to troubleshoot the startup of a container or a pod inside of Kubernetes. Lots of value. All right, fingers crossed. Let's ask SQL Server some questions. Yay, awesome. So just, hey, SQL Server, add version, server name, and add version. So here we see I'm running CU11. Super cool. All right, so let's go ahead and create a database. Very simple. I'm just going to throw the create database test DB1 at my SQL Server. So right now, when SQL Server started up the first time, it put all of its databases on storage external to the pod and mapped that to var opt MSSQL because that's what we defined in the YAML file. So my storage is actually node local inside of my cluster, mostly for demonstration reasons. If you're doing this for real, you're going to have it somewhere on a SAN, or if you're doing it in Azure, you're going to have it on an Azure disk or something like that. But it lives in this physical location in data/MSSQL. And so here you see data and logs. If we go peek inside of data, we see the master was created a few minutes ago and test DB1 was created just a few minutes ago in the demo. And so that stuff lives in that physical location. And it's the job of Kubernetes to map that into the pod in the location that SQL Server wants it to live in, which is going to be var opt MSSQL, right? So here's all of those databases, and that's where SQL Server thinks that they are because the container is, or Kubernetes is mapping that into the container at that location, right? The PV and the PVC are being presented into the container at var opt MSSQL. I'm going to skip kind of going into the storage model, which is what I would do right there, and kind of get into some gory details about that just to pick up some time from troubleshooting, because I want to show you this. Let's crash SQL Server. Bang. Right? SQL Server shuts down. Now, this is at the application level, right? And so we didn't make any changes in the Kubernetes world, but Kubernetes is smart enough to say, hey, you know what? That process terminated. And what's it going to do? It's going to react and start up a new container for you. So here we see 2 minutes and 31 seconds ago was the first entry where I created a container. It happened a second time 12 seconds ago when I crashed the container. Kubernetes just fixed that for me, right? And so if I go back and I run, let's say this query again, SQL Server's back up and running. And that's pretty fast, right? To see, I mean, of course, the crash recovery, things like that. But that didn't need to occur because we don't have a lot of data in there. Now, let's go ahead and fully delete the pod, right? We're going to take the pod and just kill it, right? And just basically throw the whole thing away. And the only thing we have left is storage, which means Kubernetes is going to come put a new pod in front of it and give us access to our data again. And that kind of decoupling of compute and data is a very powerful thing, right? Because people don't really care about SQL Server being up and running. What they care about is getting access to that data. And if all I need to do is have something like Kubernetes put a container in front of that data for my users to get access to it, then they're going to be happy, right? And so there we go. So we deleted the pod. We're going to see that we're already up and running with a new pod. And the way that I know that is the old pod name ended in T8F5S. We have a new pod, NGXSM, up and running already. So in this case, Kubernetes pulled the new container down, reverted back to the original state of that container image, attached the databases, or attached the storage. SQL Server looked in var opt MSSQL and found its data, right? That's pretty cool to be able to do that. Let's go a little bit further. Let's see, we have about 6 minutes. Let's go a little bit further and let's upgrade SQL Server. One line of code, ready? kubectl, we're gonna record this as an option, which is gonna store the metadata about what we're doing right now. We're gonna kubectl, we're gonna modify our deployment, and we're gonna set the image for the MSSQL deployment, and the container is going to be changed to, it's kind of running off the side of my screen here because of this little guy. All right, there we go. It's going to change from CU11 to CU12. So let's go ahead and do that. I'm going to upgrade SQL Server. I'm going to check out the status of my deployment. So SQL Server, or excuse me, Kubernetes is shutting down the old pod, starting up the new pod. Boom, I've upgraded SQL Server. If we go ahead and look in here, we see that there are 2 replica sets still up and running. The old replica set, and then an 8.4D, which is scaled down to 0, and the new one, 6B7, which is scaled up to 1, right? So now we're running a CU12 container. Behind the scenes, if you've upgraded between versions of SQL Server before, you know there's like upgrade scripts that are running in our SQL Server. So if I do this right now, it might be the case that we can say that only administrators can connect at this time because SQL Server is getting itself upgraded. But this still doesn't take very long because it's already done, right? CU12. We just upgraded SQL Server like that with one line of code. If you find that you do need to get in there and look at some errors, you can ask Kubernetes for the error log, kubectl logs of the deployment that you're working with. And there you see the actual SQL Server error log. So you can follow the status of any upgrades or anything like that. Or if you're troubleshooting the startup of a container, you can use kubectl logs to do that as well. You saw that when I was trying to troubleshoot it initially. It was like, all right, what's going on? This kubectl logs was one of the commands that I executed. All right, let's do something even crazier. Let's roll back. We're CU12. Let's say there is a bug in column store with an access violation, not picking on any particular technology or technique. But let's go ahead and say, hey, Kubernetes, what versions of this deployment do you know about? Well, there's the initial one, version 1, and there's the one that we just changed to version 2. All right, well, guess what? kubectl rollout, undo, deployment, which one? The one that we're working with. And I'm going to roll back to version 1. Boom. It's going to shut down the CU12 container, start up the CU11 container, attach the storage, and I'm going to be back on CU11 in a matter of seconds. And so let's go ahead and we can watch that process again. If you go and look at kubectl describe deployment, you'll see the event log here at the bottom, basically, and you see the state transitions, right, from 0 to 1, from 0 to 1 for the different versions of the replica sets that we were working with as we moved between the two. So that's where you can follow the status if you need to. So hopefully now, when I ask SQL Server for its information, so right now it's running the upgrade scripts again. There is a trace flag that you can add for demos only that would short circuit that so you don't run upgrade scripts, but it runs quick enough for me because I'm already back on 11. That's pretty cool. If something went wrong, you can use kubectl logs to get that information out of the container. So we just did some pretty cool stuff there, team. We went through a recovery scenario. We crashed SQL Server. Almost instantaneously, Kubernetes fixed it. We deleted our entire SQL Server. Kubernetes fixed it. We upgraded from CU11 to CU12. Something went wrong. We went back to CU11 with just a couple lines of code, right? That's pretty powerful in how to get things done inside of a cluster. And we also had a really good troubleshooting session. Fantastic. So let's keep moving forward. I'm gonna, let's see. Yeah, I think we have, do you mind if I go like 2 minutes over? Is that okay?
I think that's
yeah,
fine.
go.
Yeah.
Okay, cool. All right, so building production ready clusters. Before you do any of this for real, right? Scalability is a big thing you have to be concerned about. When you want to deploy, you have to make sure that you have the right number of nodes to support the workload that you want to deploy in production. Again, to kind of go back to the VMware analogy, you know, when you're building VMware clusters, you want to make sure that you have enough CPU and memory and compute to deploy the workloads that you can actually deploy. We need to be worried about inter-cluster communication, right? Can the nodes all talk to each other in a redundant way, right? A very critical piece of functionality there. If you want to have high availability for your cluster, the components that you need to focus on are the API server and etcd, right? Those two things need to be up and running at all times for your cluster. If one of those two things crashes, it's not going to bring down the whole cluster. You just won't be able to make changes to your cluster. So again, similar to vSphere. vSphere goes away, your cluster doesn't go away, but your ability to do anything with your cluster does. But if you want high availability for those services, you're going to load balance the API server because it's just an HTTP service. And etcd, you can have multiple replicas of the etcd database. That's all built into the etcd software to be able to replicate between multiple replicas. DR, of course, we want to have backups of etcd because that's a database that's going to persist the state of our cluster. And of course, any data that's stored on persistent volumes, you need to protect. So if it's SQL Server, of course, you know, you have the ability to just run backups. You can just back up to something like you do today. Or, you know, if you're doing some fancy storage level things, a lot of the storage vendors have the ability to deal with that inside of a Kubernetes cluster. Now, I threw this out there because think about this. It's not just me talking about how cool Kubernetes is. Microsoft is building their next generation software using this platform. This is a big data cluster, right? Looks like it's super complicated, and it is an infrastructure, but this is all software-defined stuff, and building infrastructure as code, and Microsoft is leveraging Kubernetes to build its next generation platform. So if they're putting a lot of time and investment and engineering into using this, chances are it's a pretty good thing for you to pay some attention to as well. I honestly like to put the crystal ball out and kind of be like the soothsayer. I think we're going to be here in a couple of years and running our core infrastructures on Kubernetes in data platforms because of the value in the things that you saw today. So let's go ahead and run through a quick review. Hopefully by now you know what Kubernetes is. We talked about API objects, how to build things in Kubernetes. We looked at how things kind of flow around inside of Kubernetes and how workload gets started up. We deployed some apps together and went quickly through production ready scenarios. So lots more resources available for you guys. I'm going to have some links and things like that we're going to blow through real quick. If you're running Docker today on Windows or Mac, you have Kubernetes. You can go and check a checkbox. You'll have a Kubernetes cluster in a few minutes on your local machine. Very, very cool. If you're running Mac, running SQL Server workloads in Kubernetes on Docker for Mac, it gets to be a little weird. Hit me up via email if you want to know more about that. Minikube is another way to get Kubernetes very, very fast, or a managed service provider like Azure, or EKS from AWS, or GKE from Google. All the cloud providers have a managed Kubernetes service, and you can get Kubernetes within a few minutes available to you from one of your cloud provider. But for me, I use Docker for Mac for a lot of the different test things that I work with on my local computer. Now I also have a locally installed cluster in some VMs. If you want to learn how to build your own cluster, check out that Pluralsight course there. For me, again, if you want free access to that, hit me up and I'll shoot you a card. No big deal. But if you have any questions now, or if you want to shoot me any questions later, please feel free. There's my contact info. So thanks everybody for having me back again. And going through those demo issues with me was pretty fun. So are there any questions, guys?
So awesome presentation. So I have two questions. One from Hiram is probably what we're all thinking. What do you tell a VP of infrastructure that states this tech hasn't been vetted and hesitates to try it out?
You know, it's those are the same VPs that are probably real apprehensive about going to the cloud in general, or like, and I think it's just about education, right? And understanding, and does it solve a business need for you, right? We don't do tech for the sake of tech, right? And so if it provides the value that you need to build your next generation data platform on, then yeah, I think the leading edge people will see that. A friend of mine is a CIO and his current organization probably isn't going to do this. He's moving to a new organization and he's like, this is where I want to start. He's like, I want to start with Kubernetes and containers because I see the value that it provides to the business in rolling out code fast, right? And that's one of the values that he wants to be able to leverage it for. And so that just goes back, you know, if you genuinely think there's a risk in running like bleeding edge code, but it's been running a lot of data centers and a lot of cloud-based applications for a pretty good chunk of time.
And the other question was actually from me. I seem to recall that this dynamic upgrade, downgrade of SQL Server databases when you switch the SQL Server core, that is starting at some compatibility level. Is it 2017 or? You
know, the funny thing is, I don't know the exact answer to that. And I emailed the product group to get an exact answer on that. And they're like, it's not documented. But we play, so they plan on building a docs article to show that. So yeah, you're right. There's some newness to that, you could say.
Cool.